Okay, this is where we're going to start getting into, instead of doing multiplication properties, we're going to start doing division properties of exponents. So basically we're going to take everything we did with multiplication, apply kind of the same set of rules with division. We're just going to change them a little bit. It's going to be the same style. You know, it's going to just be with division now instead of multiplication. What I mean by that same style is this. You know, the first thing we did was multiply two bases together, and then we did what with those exponents? Multiplying two bases together, you what? Starts with A. You add the exponents together. Okay? Here, we're going to start with two division problems, Matt.
My phone is ringing against my mom. I see what you mean.
Nope. Okay. Here, we're going to start with two problems. Alright? We're going to figure out what these are by basically doing our rules. Okay? So I want everybody to think about this. 2 to the 7th is going to be a pretty large number. So is 2 to the 4th. I'm going to tell you right now, though, that answer is 8. Okay? That answer is 8. You're probably asking, how did you get that so fast? Simple. How many 2's are on top? 7. Four on bottom. And for everyone on top that's on bottom, I can do what with? You can cancel them out. So, goodbye, see ya, so long, adios. Which means you're left with how many 2's? 3. Okay. Which means you're left with 2 to the 3rd, which in turn is 8. 2 times 2 times 2. Shortcuts what? Subtract them. Okay? Just like how you multiply the bases, you add the exponents. When you're dividing same bases, you're going to subtract the exponents. Okay? Because of the way they cancel, like I did on the 2's. Alrighty? Everybody good? The bottom, t to the 4th over t to the 3rd is going to be just what then? T. Technical terms, it's called the quotient of powers. Just like the other day, you can write the title of it, and then there's going to be a little bit of letters to show examples of. So, you know, like right there, basically, is what I want you to make sure you get away from it with. You take the same base, you subtract exponents. Okay. Now, once you start dividing, once we start doing these, this is going to get a little bit more complicated than just add or multiply. Because we're going to do those two things, we're going to do this, okay? Right here, this quotient of powers, in my opinion, is one of the most important exponent rules you can know. All right? Because if you know this, then you can figure out any problem I hand you, as long as you know this rule, okay? If you notice also, both times, when we have, like, for example, when we have c to the 11th over c to the 8th, what's the operation? It's subtraction, yes, but what are the order of the numbers? No, that's not necessarily, but also from what they're set up as in the division. Right? Right here? See this? Yeah. We have c to the 11th over c to the 8th. When we actually subtract them, which one goes first?
C11.
11. 8.
Oh, numerator then denominator?
Numerator is exponent, then denominator. Look here in the general case, okay? A to the m over a to the p, you do m minus p, top minus bottom, okay? That's the order every single time, top minus bottom. If you remember that, you're in good shape. Matt?
I'm sorry to interrupt, but my mom is literally like...
Go to the office then. Go.
Thank you.
So now, remember, there's going to be more bases. Like I said, it's going to be more than just one base. But you just apply that rule for each individual base. Okay? So we have g cubed h to the 5th over GH squared. All right. So we have, I'm going to show all my work here first, okay, just for the first one here. So we have G is going to be to the top exponent minus the bottom. So 3 minus 1. And then H is going to be H to the 5th minus 2. So 3 minus 1 gives us what? 2. 5 minus 2 gives you 3. That's simple. G squared, H cubed. Alright, so the first one we have x cubed y to the 4th over x squared y. So we're going to subtract the exponents on x. So 3 minus 2 is going to give us what? 1. So we'll just have 1x. And then y to the 4th over y is going to give us y to the 3rd. Alright. Second one, k is going to be k to the k squared, m to the 7th, and then the p's, since they eat 1 for 1, they cancel out. So k squared, m to the 7th. Questions on that one? Alright, next rule. Going to be similar to the power of a product rule. It's the power of a quotient rule. Okay, so I'm going to ask you guys this. Whenever we had, or power of a power rule, I guess it would be. Whenever we had 2x squared last time, you would do what? Bertelsmann.
Do 2 times 2 and then x.
Square the 2, square the x. You square everything inside of parentheses, right? Everybody remember that? Okay? Down here with your quotient, same deal. Okay? You're going to square or take everything inside the fraction now to that power. So same rule, different setup. Okay? One rule's talking about when you got a multiplication going on. This one's talking about when you got a division going on. But the same thing. You take it to everything. Okay? So if you look down here, I like the variable examples more. You know, the numbers, you can figure out the numbers, but the variable ones are the good ones. R over T all to the 5th, so it's R to the 5th over T to the 5th. You just take it to each one. Okay? This is where this gets fun. We have, inside a fraction, we have 3p cubed over 7. And that whole fraction is being what? Squared. Okay? The whole fraction is being squared. Okay? Now, I have one piece of advice. Before you start, look inside the parentheses. If something simplifies in here, do it. Okay? If something simplifies inside the parentheses, then do it. Nothing does, though. Okay? Nothing does. Alright? So now we're going to start applying all these rules. So here's what we're going to do first. We have to take care of this big exponent. Okay? Which means we're going to square the top, square the bottom. Okay, so that's what we're going to do first. And I'm going to write this out. So the top is 3p cubed, and it needs to be squared. The bottom is 7. It needs to be squared. Okay. So then, just like how we just talked about with 2x, we got to do 3p cubed squared. So what's 3 squared? 9. Too big. Okay. What's p cubed squared then? P to the 6th. All right, 3 times 2. All over, what's 7 squared?
49.
49. Okay. So you're comboing, if you've picked up on this, you're comboing your power of a quotient rule with your power of a product rule, since there's two terms in your numerator. Everybody see that? So whenever I say, for this exponent of 2 here, you square top, you square bottom. You do, but you square everything inside. Okay? So this is a good example of why I'm lenient on the work showing here. I can see people needing to show, okay, square the top, square the bottom, and then actually do it. Okay? I can see that. And that's fine. I'm not hating on y'all. I can also see people saying, all right, here's a square. So 3 squared, 9. P cubed squared, 6. 7 squared, 49. And still going straight to the answer. Okay? I can see both ways. Does that make sense? So whatever you need to do, that's why I say as much work as you need to show me is the work I need to see. Everybody good? All right, so the first one, cube top, cube bottom. Okay, and here's what I'm talking about with the work you need to show. All right, I'm still going to show it just for benefit of everybody. So 3x to the 4th to the 3rd over 4 to the 3rd. Okay, and then cube all 3 parts. So what's 3 cubed? 27. 3 times 3 times 3. X to the 4th to the 3rd gives you x to the 12, multiply, all over. What's 4 to the 3rd? 64, okay? You guys know how to do exponents in your calculators? You got, where's it at? Is it above divide? Is that where it is? I'm trying to think without looking. Yeah, if you look above your divide button, all right, let me, I'll show you a little bit. Let me do this one, then I'll show you, okay? So this one here, we're going to cube top and cube bottom again, except what's different about this one? How many terms do we have in each one? On the bottom you have 2 terms as well. Okay, so 5y to the 4th to the 3rd. Okay, so we just figured out that 4 cubed is 64. X to the 3rd is going to give us x to the 9th. What's 5 to the 3rd? 125. And then y to the 4th to the 3rd is going to give us y to the 12th. Good. As long as, okay, that's the key. As long as these numbers don't reduce inside, they won't reduce out here either. Okay? So as long as these numbers in here don't reduce, I'm talking about the 4 and 5 right now, they won't reduce outside here either. Everybody good? Right there, the button that just lit up in red, right there, that's your exponent key. Okay, so if you don't want to do, so say you want to do 5 to the 3rd, so it would just be 5, caret, 3, enter, boom, done. Okay, in case for those that don't know that, all right? Good enough. You could get to square and keep. There's a special square button also. So say you want to do like 7 squared, it's over here above log. Okay, it's squared itself right here. You can also get to cube if you go through your math menu. I just think it's easier just to use your caret to get wherever you need to go. All right, so just a little helpful hint. Alrighty. Okay, next slide's going to be, we're going to go through this real quick because we already mentioned it. It's called the zero exponent property. Symbols. For any non-zero number a to the 0 equals 1. So anything to the 0 power is 1. Okay? That's what you need to write from this slide. Anything. And highlight and underline and put flashing lights around anything to the 0 power is 1. Alright, so we have 2 examples here. I'm going to go through kind of quick. So the b's, you have 2 b's. So you're going to subtract them like you've been doing. So 4 minus 2 gives us b to the what? B to the 2nd. That was ugly too. Let's try that again. C to the 2nd over C to the 1st is going to give us C. And since d is to the 0, that's going to just become what? 1. All right? Now, that 1 doesn't go away. Okay? It's still there. But what operation is going on between the b squared, the c, and this 1? Multiplication. And 1 times this is just going to be b squared c. Okay? So you don't need to write the 1s here. Okay? What's the answer here? 1. Very good. Who said that? Mackenzie Wagner. Why 1? Are you Mackenzie Wagner?
Because it says any non-zero number raised to 0 power
Is 1. Good. Okay? There's mumble jumble inside here, right? You got f's to simplify, you got g's to simplify, you got h's to simplify. That's all good. But the whole entire thing is taken to what power? 0. So long story short, you're going to have to take the 0 to the whole top, the 0 to the whole bottom, and when you do that, it's all going to become 1. So your answer, 1. Okay, last property we're going to learn. Okay, remember how I said there were 7 of them? This is the 7th one. This is probably one of the hardest. Okay? It's called the negative exponent property. Negative exponents are bad. No good. Alright? Can't have them in your problems. And they're going to start showing up. Starting today. Okay? They're going to start showing up. Basically in words, for any non-zero number, whatever number, okay, you're talking about, any integer, n. A to the negative n is the reciprocal of a to the n. Also the reciprocal of a to the negative n is a to the n. Holy crap, that's confusing. Okay? What you need to write is those two. Write those two down. What's reciprocal mean? Anybody remember from our chapter 4 days? The reciprocal of a fraction. Let me give you a fraction. 2/3. Its reciprocal is 3 over 2. What'd you do to that fraction, Melinda?
Flip. Oh my bad.
Well, you're getting closer. You flip it, yeah. Okay, switch it, flip it. All right. Now look up here on those two examples. You have 2 to the negative 4th as your starting point. What did they do to 2 to the negative 4th?
Made the 4 positive.
How so? They didn't just do it because they felt like it. They did something else to it also.
They added
Where's 2 to the 4th at now?
Multiplied it by itself.
Not necessarily.
Oh, it's in its reciprocal form.
It's in its reciprocal form. There you go. Very good. Okay. Everybody see that? Okay. You took 2 to the negative 4th. Only difference is took it to its reciprocal form, and then once you moved down, you made it positive. Okay. This stems from your subtraction stuff. Okay. So you're not trying to get super technical about it, but that's where this comes from. Okay. It comes from your subtractions. Okay. Same thing, however, goes if it's negative on the bottom. Reciprocal it, flip it, make it positive. So wherever it's negative, it's positive on the other side. Okay? Everybody kind of okay with it not for now? All right, it's going to help once you start seeing examples. I know that these words for this one's not great. Okay? Examples is what helps this. All right? Are we good for now? Okay. Before we get to examples, though, we have what I call the 4 rules of simplification. Yes, that's bright pink. Holy cow. Pretty. Change the color on the slide. Think that matters?
Yeah.
Actually, in this case, yeah. Usually I don't really do, color changes, who cares, but it's a little hard on the eyeballs. It's the point. It's supposed to wake you up.
You're making my eyes worse.
I'm sorry.
They already are.
They make mine worse too, but I look at it every year. Power through though, write these down. An expression is considered simplified when, number 1, you contain positive exponents. No negatives. Number 2, each base appears once. Number 3, no powers of powers. Number 4, all fractions are simplified. This is what I look at when I grade. These 4 things. Okay, to basically judge my partial credit. All right. If you get most of these things, you're going to get a lot of partial credit. If you don't get most of these things, you're not going to get a lot of partial credit. Okay, now, this is where this kind of gets, and this is where I want to make this make sense a little bit, okay? I want to make this make sense with the R's. Okay? So for now, we're focusing on just the R's. Okay? The problem is n to the negative 5th, p to the 4th, over r to the negative 2nd. I'm going to take care of the r's first, and to show why this switching works, what I'm going to do is I'm going to add into the problem. Okay? I'm going to add in an r to the 0 power. Okay? Now, did I do anything wrong with doing that? No, because r to the 0 is 1, and 1 times what we have there is just what we have there. So no harm, no foul. Okay? Everybody cool? Okay, now, with this r that I added in and this r that's down here, what do I do with these two exponents? What operation? Subtract. Yeah. Not a lot of confidence there with that answer, Mr. Wilson, but we'll go with it. Subtract. Okay? So, what is r to the 0 minus a negative 2?
A positive 2.
Positive 2. Okay? That's what allows you to just take this r to the negative 2nd and move it up.
Okay.
Okay? Does that help make it make sense as to why this works? Everybody good?
Then how would you change 10?
The other one, the negative 5, you just kind of have to roll with on the same logic of flipping it.
Wait, what?
Okay?
So
Because
would you just put an n to the 0 over it and then put n5 below it?
moving them from bottom to top, well, Allison, is what makes this, is what example for that to show. The ones where you have to move them from top to bottom, you just have to use that rule backwards. Okay, you don't really use this. I'm never going to write r to the 0 in there and do that. What I'm going to tell you guys to do, Dylan, you done? Thank you. Moving this one up top. Dylan.
Sorry.
Moving this one down. That's all you got to do. Okay? So, equals. P to the 4th stays where it's at. Everybody see that? Okay, P to the 4th, r squared over n to the 5th. Wherever they're negative, move them to the other side, and you make them positive. Not the most complicated it could be, but getting there. Okay? Getting there, though. There's a lot going on here. Okay? And there's a lot you have to keep track of. So, what I'm going to do is I'm going to teach it one way. One. Okay? So, everybody, right now. If you can go on your own and figure out the little tricks and figure it out from there, by all means, please do so. And if you need to confirm with me on those tricks, please do so. But as far as teaching this to the masses, I'm doing this one way. All right? So we have 5 r to the negative 3rd, t to the 4th, all over. Negative 20 r squared, t to the 7th, u to the negative 5th. Okay? First thing I'm going to do is look at my numbers. 5 and negative 20. Do they reduce? Yes, to what? Negative 1/4. Everybody cool with me moving my negative from the bottom to the top? Okay. It doesn't matter which side's negative as long as one side is. And preferably the top be negative. Okay? Everybody good? Okay. The way I'm teaching this is this. Remember that first rule we did? Okay? Quotient. The quotient rule. We did what with those two? We did what operation? Subtraction. That's the way I'm teaching this. Subtract them. So R, you have -3 minus 2, and I'm showing all my work on this one. T, 4 minus 7. And then the u to the -5th I'm going to keep down below for now, since there's no u's up top. Okay? So, what's -3 minus 2?
-5.
So R gets a -5 exponent. What about T? It gets a -3 exponent. Let me move this away from the denominator just a little bit. There we go. Over 4, u still to the -5th. These all three are negative, so all three of them have to be what? What do we have to do with all three?
Flip.
Flip them. Okay. Flip them, make them positive. So the R comes down, the T comes down, the U goes up. Where's the 4 go?
Stay there.
It stays there. Good. Okay? The 4 stays. Because what's its exponent? What's 4's exponent right now? Positive 1. So it doesn't move. Alright? So you move only negative exponents. So on top you're going to have u to the 5th over 4 r to the 5th t to the 3rd. The first one, the w's do what? Cancel. What else? What else do you have to do then? Dalton.
I put the V, the -3 below.
Okay. And?
I put the Y and the -6 above.
Good. Anything else?
No.
Nope. That's it. W's cancel. X squared stays where it is. V's move down. Y's move up. Make them positive. Okay. That's number 1. All right. Second one, 32 and 4 reduces to what? 8. Okay. Now, here's where I'm talking about with how I'm teaching this. I'm doing my subtraction rule on all 3. Okay. So I do -8 minus 3 to give me -11. I do 3 minus 5 to give me -2 on my B's. -4 minus -2 to give me -2 on my C's. Okay. Everybody see that? Then what? Now I have to do what? Move them all 3 down and change them to a positive, okay? I'd much rather see you guys do it like that starting out. Apply one rule, and then if you have to, apply the second one. Here you had to apply that negative exponent rule 3 times. That's okay. All right? And that's it. Okay? Fraction simplified, each base happens once, yada yada, all good. Third one. Remember what I said about inside fractions. Is there stuff you can simplify on the inside? Yes, there's a lot you can simplify on the inside. For example, 5/25 becomes 1/5. The J stays where it is. The K's you subtract. And the M's you subtract. So that's my first line. Maybe it's not yours, but you might still be on the right track. Okay? Now, from here, in my mind, there's still stuff I can do on the inside, and that's what? Nope, inside. I can make my exponents be positive. So I do that next. Okay? So I keep my K, I move my J, I move my M's. All right. Last thing to do is what? Square everything. Okay. So k to the 12th over 25, j to the 6th, m to the 8th. Sorry, I ran out of room on that one. Okay. Now, a couple of different things. Right here, at this step, if you squared everything first, and then move your negative exponents, did you do anything wrong?
It was 2 today.
Right here? You would eventually gotten the same answer. Okay? If you just squared right here and then move. Okay? There's also a trick with this one about knowing what way to move your exponents, okay? So there's a lot of little things within here that as you get better, you will recognize. That's what I'm talking about with the little tricks. So if you find something and you want to see if you're right, let me know, and I'll let you know. Okay? Anthony, stretching? What's up?
Why do you have to move the 20?
Still.
Page 402, 1 through 17. Due tomorrow. No quiz tomorrow. Okay? Due tomorrow.